YouTube channel. In this video lecture, I am going to answer all the questions from Ground Radar chapter, Keith Williams Radio Navigation book. So let's begin with question number 1. What is the typical range of a terminal area surveillance radar? Okay, so terminal area surveillance radar up to 25, up to 80, up to 250, up to 2500. So correct answer is option A. Terminal area. Terminal area is that airspace which is a confluence or intersection of many airways originating from the airport environment and transitioning all aircraft from airport environment to area, whatever area you are flying in. Okay, so terminal area falls in between the airport and the cruise portion, which happens mostly under supervision of area controllers. So terminal area is radar will operate up to 25 nautical miles. Option Charlie, up to 250 nautical miles belongs to area surveillance radar. Okay. Next, precision approach radar at a military airfield has both an azimuth and elevation element. It must be able to provide accuracy within what? Okay. So plus minus 20 feet elevation and azimuth, plus minus 30 feet elevation and azimuth, plus minus 30 feet elevation, plus minus 20 feet azimuth, plus minus 20 feet elevation, and plus minus 30 feet azimuth. Plus minus 30 feet in elevation and plus minus 20 feet in azimuth. Remember this fact. Next, what is a typical range for en route surveillance radar? En route means area surveillance radar. So it is a long range, very long range between 200 nautical miles and 300 nautical miles. So this is that answer. Next, in which frequency band do most airfield surface movement radar systems operate? So airfield surface movement radar operate in the frequency band of super high frequency 15 GHz to 17 GHz. A radar used by ATC has following characteristics: long wavelength, right, and serial rotation rate which is very low, 5 rpm. It is most likely to be airfield surface movement radar, precision approach radar, en route surveillance radar, and terminal surveillance radar. So now airfield surface movement radar has a scan rotation rate of 60 rpm. Okay, so definitely option A is not the option. En route surveillance radar and terminal surveillance radar. So here the correct option will be option Charlie, en route surveillance radar. Next, it's given in the theory chapter in the beginning of the Oxford textbook. So make a column for radar, and in the corresponding column, say next column, you can write the corresponding ranges. That way you can remember it. During surveillance radar approach, the vertical position of the plane is given in terms of what? Very important question. In terms of surveillance radar approach as well as precision approach radar. Okay, precision approach. The vertical distances are with respect to QAP, aerodrome level pressure, that is heights with respect to touchdown zone of the runway. So correct option is height above aerodrome QNH, wrong. Height above aerodrome level, height above QNH, height above QFE threshold. So here the most correct answer will be delta, height above QFE threshold. Question 7. Aerodrome ground movement radar is likely to operate in super high frequency band with a scan rate of 60 rotations or revolutions per minute. Next. Why does surface movement radar use a frequency in the super high frequency band and not EHF? So the reason is that in extremely high frequency band, the errors caused by attenuation of radio signal is more are more severe than the errors caused in the super high frequency band. Okay, so that's why. So super high frequency band gives better definition of aircraft type than EHF. EHF is absorbed and scattered by moisture in the air. Switching to super high frequency reduces this problem. Yes, it reduces this problem, doesn't eliminate it completely, reduces it. So delta is the correct option. Surface movement radars operate mainly in the super high frequency band as opposed to extremely high frequency band because EHF is more expensive. No. EHF is likely to detect more moisture in the atmosphere. EHF band doesn't provide sufficient frequency spacing. EHF radiated power is more dangerous to users' health. So the correct answer is option Bravo. Extremely high frequency is going to get affected or influenced by moisture in the atmosphere. 10. A moving target indicator rejects all stationary targets, rejects all moving targets, is only effective if the target moves directly towards the ground unit, is only effective if the target moves away from the ground unit. So correct option is option alpha. A moving target indicator will reject all echoes or pulses coming from fixed objects like mountains, towers, obstructions. It will only show representations of moving objects like aircraft, mainly aircraft, right? So that is one purpose of moving target indicator. The disadvantage is that since the radar controller is not able to spot fixed objects on its radar screen like mountains, availability or presence of mountains, obstructions, towers, the radar controller may navigate his aircraft or guide his aircraft towards that obstruction or a fixed object. So that is a disadvantage. The advantage B, the reflections from stationary objects are not reflected or are not represented on the radar screen. So remember this for your Viva. Very important. This paragraph. Surveillance radar equipment incorporates circuitry designed to eliminate returns from stationary objects, which would give returns that would mask the weaker returns from aircraft. By erasing the permanent echoes, the radar is able to display only the moving targets like aircraft. It is possible for a radar receiver or moving target indicator to produce false targets as a result of second trace returns. Okay, and the second trace returns are removed by changing pulse recurrence frequency between consecutive pulses, a technique known as jittering the PRF. Very important point for your ATPL written exam. So remember this. Next, short range aerodrome radars will have wavelength which are centimetric. So short range aerodrome radars nothing but airport surface movement radar, and they operate in the frequency band of super high frequency, and super high frequencies have wavelengths in the range of centimeters. 12. Types of radar approach: surveillance approach and precision approach. Okay, surveillance approach based on surveillance radar and approach based on precision radar. So option Charlie is the correct option. Precision approach radars are required under the ICAO specifications to indicate aircraft within the following parameters. Important: azimuth 20 degrees, vertical 7 degrees, range 9 nautical miles. Remember option Bravo. A similar question was in the ground radar chapter from Ground Studies for Pilots GSP textbook. I've solved the questions from that textbook as well and uploaded to my channel. Do watch that video lecture. An area surveillance radar is most likely to have a frequency of what? Area surveillance. 350 megahertz, 600 megahertz, 100 hertz, 150 hertz. So it is most likely to have a frequency of 600 megahertz. The maximum range obtained from ATC en route area surveillance radar is approximately 200 to 300 nautical miles. The maximum range of a ground radar. Now very important point. I have covered this many times in many different lectures based on radar. Maximum range is inversely proportional to pulse recurrence frequency. Minimum range is directly proportional to pulse width. So over here maximum range will be limited by pulse recurrence rate or pulse recurrence frequency. A ground radar transmitting at PRF 1200 pulses per second will have a maximum unambiguous range of how much? So range is equal to speed of light divided by 2 into frequency. So range will be equal to 3 into 10 raised to 8 meter per second divided by 2 into 1200. So that will be equal to 0.125 into 10 raised to 6 meter, or 125 kilometer, or 67.5 nautical miles. So option Bravo is the correct option. If radar has a beam width of 3 degrees and a pulse length of 4 microseconds, the target azimuth resolution at a range of 60 nautical miles will be approximately how much? So again 1 in 60 rule based sum. Here is a transmitter. Okay. There is one aircraft here. The azimuth resolution is depends on beam width. Okay. So aircraft in order to be represented on the radar screen, okay, properly. That means two aircraft, two different representations. So that in order for that to happen, the two aircraft must be situated outside the beam width. Outside the beam width. Okay. If they are situated inside the on the beam width or inside the beam width, both these aircraft will be represented as one radar reflection. Okay, so in order to get azimuth resolution, both these aircraft must be outside the beam width. This is the distance between them. Now beam width is at an angle of 3 degrees. The distance from the transmitter to the aircraft is 60 nautical miles. And now we have to find target azimuth resolution. That means we have to find the distance between these two aircraft, lateral distance. In order to find that lateral distance, we will first consider one triangle. We will consider this triangle, the upper triangle, this one. Okay. So the distance is 60. The angle will be, total angle is 3 degrees. So 1.5 here, 1.5 down below. And now we can find out this x. We know the formula, angle equals to distance of track upon distance gone into 60. So 1.5 degree, distance of track s, x, distance gone 60 into 60. So x will be equal to 1.5 nautical miles. So if this is 1.5, this will also be equal to 1.5. So total becomes 3 nautical miles. So that will be your answer. Next, question 19. A surveillance radar element used to provide approach guidance doesn't have height determination capacity, can only be used to a point 3 miles from the threshold, may not be used in heavy rain because of high levels of signal loss, can be used to give guidance both horizontally and vertically. The surveillance radar can be used to is a 2D approach, meaning you are only given horizontal guidance and only and just advisory height information. In precision approach, okay, approach based on precision radar, you get both horizontal guidance and vertical guidance. So that can be regarded as 3D approach. So delta is wrong. Surveillance radar approach terminates 2 nautical miles from the threshold or sometimes 0.5 to 1 nautical miles also. So Bravo is wrong. because of this word only. May not be used in heavy rain because of high levels of signal loss. So that is wrong. So correct answer is option A. Does not have a high determination capacity, and therefore the information given to you with respect to uh, vertical is advisory. Okay, it's upon the pilot to use that information and adjust his glide path. Next, question 20. On which of the following radar displays is it possible to get an indication of the shape and to some extent the type of aircraft? So this is only possible with one particular radar which uses very high frequency, that is super high frequency, and the scan rate is also very fast. So that radar is aerodrome surface movement radar. Next, 21. A surveillance radar installation will often consist of what? A secondary surveillance radar and a precision radar, a primary radar and a secondary surveillance radar, a primary radar and a VDF, a primary radar and a precision radar. So always remember surveillance radar. Surveillance means monitoring, supervision. So this radar is made of two parts. A primary radar, which gives the position of aircraft in terms of its bearing and distance from the transmitter. Secondary surveillance radar will give additional information with respect to type of wake turbulence category of aircraft, speed, height information, flight level, call sign, transponder code, right? So option Charlie is the correct option. A surveillance radar will be made of two types of different radar, secondary and primary. In order to be able to penetrate cloud, a primary radar signal must have what? Now see, a high PRF, a short wavelength, a long wavelength, and a high frequency. So correct option is long wavelength. Let's say there is a cloud here, and there are many clouds behind this particular cloud, and there are water droplets in this cloud. So are there in the next clouds. Now, if wavelength of the transmitted signal is equal to the wavelength of this water droplets, that means the radio signal is as large as water droplets, the signal will get reflected. The signal will get reflected. The signal will get reflected. Signal reflects. Now, if the wavelength of this signal, if the wavelength of this signal is much more than wavelength of water droplets, what will happen? This signal will penetrate this cloud layer and go past it, okay, go beyond it. So that's why we need a long wavelength in order to able to penetrate cloud and go beyond that cloud. Next, question 23. Surveillance radar approach may be flown 2 nautical miles using QFE unless the pilot advises the controller that the approach is to be flown on QNH. Okay, sounds okay. zero point 0.5 miles using QNH unless the pilot advises the controller that the approach is to be flown on basis QFE. 0.5 nautical mile using QNH only. Point correction, 2 nautical mile using QFE only. So the correct option is option alpha. 2 nautical mile using QFE. QNH is optional. In option Bravo, it states QNH is mandatory, QFE is optional. That's wrong. So 2 nautical mile is the usual distance. It can go down to 0.5 miles also. Okay, using QFE, mainly QFE. Upon pilot's request, that can be changed to QNH. A long-range ATC surveillance radar will typically use a frequency of what? So a long-range ATC radar. So it will use a frequency of ultra high frequency band. Okay. Next. Aircraft surface movement radar, very important question, operates on frequencies in super high frequency band. There is an antenna that rotates at approximately 60 revolutions per minute, 60 revolutions per minute, and it is sometimes possible to determine the type of aircraft from the returns on the radar screen. So the correct option will be option Charlie. That's it. This concludes our lecture, and with this we have solved all the 25 questions based on ground radar chapter 8 periods. Not a very important chapter, but it's good to have knowledge about this specific radars because they will be relevant to practical flying. CPL in CPL exam you won't get you're not expected to get questions from this, but ATPL exam yes, ATPL exam the questions from this chapter will surely dominate the ATPL papers, at least 3-4 questions. So do this ground radar chapter very well, whether irrespective of CPL, irrespective of your stage of career, whether you are CPL pursuing CPL training or ATPL or airline, it's good to have knowledge of this equipments that we use in daily lives. So I thank you for your time. Subscribe to this channel, hit the like button if you have liked this video lecture, and share this video with all your pilot friends. All the best. I'll see you in the next video lecture.